Hi, my name is Vivian Zhong. I'm a junior working in the Elm Lab doing microbiome research. And my current project revolves around this treatment called fecal microbiota transplant. This treatment involves taking the stool from a healthy donor and transplanting it into the gut of a sick patient. And this is a really effective cure for a disease called recurrent C. diff infection. However, it's not really that effective in many other diseases that are similarly related to the microbiome. And we want to look into what affects the efficacy of FMT, what factors play into whether or not the bacteria in the donor stool colonize the patient gut. And so the two factors that we looked into in my project, one is whether or not the stool prior to transplantation was exposed to oxygen or not. The idea behind this is that your gut is a very oxygen deficient environment, but the usual processing method currently used in clinical trials and in medical centers involves exposing the stool to a large amount of oxygen. And so perhaps that's enough to alter the microbiome composition of the donor stool sample enough that it impacts how well the bacteria colonize the patient. And the second factor is to look at whether or not perhaps the sheer difference in the donor, since everybody has a very different microbiota composition, perhaps just interdonor variations have a large effect on whether or not it's on how the donor stool interacts with the patient. So we did a clinical trial with 3 donors and 11 patients. We took stool samples from the donor and from the patient both before and at 4 time points after the treatment was given. And long story short, we looked at the composition of the stool samples, and so far it doesn't seem like there's a really large signal to indicate any difference between patients that were treated with oxygen exposed or not exposed to oxygen stool, and what might be either covering any signal from that effect, or which might be more important than whether or not the stool was exposed to oxygen, is the interdonor variations. Preliminary results indicate that the stool from one of the donors was perhaps worse than the other 2 donors for the bacteria to colonize in the patient gut. And in the future, I'm going to do some more analysis of the data, looking at more at specific bacteria, whether those perhaps do differ between oxygen and non-oxygen exposed, and also looking more at, are the donor-specific effects, are they because of the differences in the composition, are they perhaps artifacts of how they were processed, to try to get to the bottom of the mechanism behind FMT.